ready to think like an attacker? Come on now, we need to attack here. We need to attack. So without further ado, y'all make some noise for Charlie Gerard.
Thank you. Oh no. Hello? Oh, I think that. Hello? Okay, I need to move the mic. Cool. All right, okay. Good, we're good. All right, thank you. Thanks everybody for joining me for my talk about, thinking like an attacker. So in this talk, what we're gonna do is that we're going to learn a little bit about cybersecurity, and we're going to learn a little bit about writing code to do bad things, but most importantly, thinking like an attacker, so switching your mindset between thinking like a builder, so how to make things work, and switching to thinking like an attacker. So if you actually wanted to find the vulnerabilities in your app, or more like specifically in the Node.js ecosystem, how would you go about being a little bit of a hacker in JavaScript? So I've already been introduced. I'm not going to spend too much time on this. Senior developer advocate at Stripe, author of a book about machine learning in JavaScript. And I usually like to describe myself as a creative technologist. I like to push the boundaries of what can be done on the web or in JavaScript, sometimes in other languages. But I love JavaScript, so I like to do all of that weird stuff in JS. And when I am not in front of my computer, I just love to be spending a lot of time outside. But why am I talking about cybersecurity today? So maybe about 6 months ago, I started reading some articles, and I realized that there was not a day that went by without some kind of news about cybersecurity attacks. So if you're not already reading about this, you might not realize it, but if you start reading into it and like Google News or whatever learns what you're interested in, they will give you articles about different types of cybersecurity attacks every day. So it could go from US news sites that are infested with malware to GitHub that had a vulnerability that let people take over certain open source repositories, to stories of nation-state threats and zero-day attacks, which are attacks that have not been known before, so there's no patches for. So hackers can find new ways to attack you all the time. And basically, there's just a huge increase in different types of cybersecurity attacks. And there's a lot of those that we can't really do much about it as JavaScript devs. So if you're, in terms of nations attacking each other, we can't really do that much about that. But as developers in the room writing JavaScript, we can kind of mitigate some of the threats that are happening in open source software, especially in the way that we're using Node.js modules. So when I wanted to learn a little bit more about how to protect yourself, usually what I like to do is be more hands-on and practical. So what better way to do this than to actually create some of these attacks yourself? So let's commit cybercrimes, and but more importantly, this is for educational purposes only. So a lot of the things that I'm going to show you in this talk are illegal. So if you do them, I hack myself. I don't hack other people. If you decide to hack other people just for fun, at least get consent to just learn more about stuff like this. So if you decide to use the knowledge from this talk to do bad things, I'm not responsible for any of it. The reason why I'm talking about this is to raise awareness so that you know the risk that you're taking sometimes when working in the Node.js ecosystem. And the more you understand the vulnerabilities that are in your applications or in the way that you're working, the more you are probably likely to understand how to protect yourself a little bit better. So in this talk, I'm going to present 3 types of cybersecurity attacks. There's a lot more than these. I only have 20 minutes, so I'm just going to scratch the surface. But hopefully, it will give you an idea, and it will get you as excited as I was when I realized that I could build some of these things myself. So first, let's talk about protestware. So what is protestware? So it's software created to raise awareness about a social or political issue, but it does not damage or take control of the user's device. So the main point of this type of attack is to raise awareness. And an example of this is an NPM package called event source polyfill. So at first, this package had nothing malicious in it. It was util. Some of you might be using it. But then over time, in one of the version 1.0.26, the author of the package decided to add this code. So if you can't read it because it's too small, don't worry, I'll tell you what it does. So it's a set timeout function that after 15 seconds redirects the user to a different website. And it shows a little pop-up, and it's a petition that you have to sign. And what it does, it looks at the location of the person who is visiting the website and then redirects them. So it's not stealing any data, it's not really deleting any files, but if you're, for example, if I was working at Stripe and I install the wrong version of that NPM module, and all of a sudden, all our customers are redirected, involuntarily to another website, it's not really cool. You break a lot of trust for your customers. So this NPM package is still on NPM, but the protestware has been removed in subsequent versions. So the issue is that sometimes we install NPM modules trusting the maintainers, and if they just decide that they want to add protestware, they will, and if you update your package without checking the code, like the difference in lines, you might be installing this. And this one only redirects to another web page. It's not that malicious, but there are other examples, especially one called Peace Not War, that was actually deleting everything on the computer of people who were visiting or who were using it from Russia. But the thing is, sometimes if you're using a VPN and it happens that the VPN is set to Russia, you might not be in Russia, but it still deleted everything from the user's computer. And you could think, well, I would never install a package called Peace Not War because I don't need it. But the thing is, the maintainer of a package called Node IPC, which is a very popular NPM package, actually did add that as a dependency. So even if you didn't think that you were using Peace Not War, but you're using Node IPC, it then requires Peace Not War, and you were basically fucked. So that's like, sorry, I was like, should I swear, should I know? Anyway, so this is like for protestware. So I said that usually it's not to, steal any data or whatever. So let's move on a little bit, more annoying and talk about ransomware. So you might be more familiar with this one, but what is ransomware? So it's a form of malware that is designed to encrypt files on a device, rendering them and the system that they rely on unusable, and demand payment to restore access. So the two important things here is that it encrypts files and then it demands payment. So you are not able to have access to your files unless you pay the attacker. So how can you do this? What does it rely on? So at first, it uses asymmetric encryption because it uses two different keys, a public key and a private key. So again, encryption by default is not something bad. I'm all for encryption, but it's one of the tools that can be used to do bad things like ransomware. So at first, if you ever want to try and tinker with that on yourself, you can use OpenSSL. You can start by creating a private key, and from that private key, you generate a public key. And what these keys are used for is that if I was communicating with a friend and I want our communication to be encrypted, I would be sending them my public key. They would encrypt the message they want to send me with that public key, send me the encrypted message, and the only person who can decrypt the message would be me because the private key, I have the private key that the public key is generated from. So in the context of ransomware, you would start by generating two keys, and then you could create a shell script that would do something like this. So that's like, this is a code sample on myself, but I'm going to go through the lines. So for example, I could, I could navigate to a folder on the victim's computer, and I'll talk right after about how you could trick somebody into actually running this. So you would navigate to a folder on the victim's computer, and using the public key that I generated as an attacker, I dynamically create a file on the victim's computer that has this public key. And then the next step would be to encrypt a folder. So here I have a fake folder called like super secret stuff. If I wanted to mess things up, I would obviously compress either my whole desktop or my entire computer. But here, again, I was testing on my work laptop, so I obviously do not want to delete everything that's on my work laptop. So I create a fake folder called super secret stuff. I compress it into a folder called gotcha.tar.gz. Then the next step would, oh no. Oh no, wait. Yeah, I mean, like that's, not because my laptop was like, I need to update Chrome. And I'm like, no, not now, not now. So, so we'll see. I don't know why it asked me to do that now. Well, let's hope that I have at least another half hour. So the next step would be to use OpenSSL to then encrypt the compressed folder. So here, OpenSSL, I use the key that I dynamically created, like the file on the victim's computer. I take the compressed gotcha.tar.gz, and the output would be gotcha.enc, so the last one. And the next lines would be removing the compressed folder, removing the original folder, so that all that's left on the victim's computer is the encrypted file. And then usually you would create, again, dynamically a text file on the victim's computer with saying like, all your files are encrypted, ha ha ha. And then you would say like, here's how you would pay me, probably in crypto, and all of that stuff. So I'm not going to go into like how to get paid because I don't know how to do that anyway. But you could imagine that you could do that research and then, but yeah, so if you trick a user into running this, all that would be left on their computer would be the gotcha.egg file and a note file that says, pay me and I'll give you the private key. And if the person pays you and you do send them the private key, then they can do the decryption part and retrieve their original folder. So here I talk about the shell script. So how do you actually trick the user into running this? So one of the things that you can do is use the script commands or install commands from package.json. So again, you could on post install or pre-install or wherever you want, run bash.script.sh. So that, when you look at this like that, it's like, oh, well, it's a bit dodgy. There's a post-install script. Maybe if you're a security-conscious developer, you do read every single line of the package.json. But I mean, honestly, who does? So one of the really easy things, you could try to think, OK, I'm going to start slowly, see if anybody runs this. We work so fast that sometimes you just like, oh, yeah, there's a package that's popular, TypeScript, whatever, npm install, and you don't realize that you might be running something like this. But let's say that you don't want the shell script to be in the source code on GitHub because maybe you know that it looks dodgy. You could actually also run this in a JavaScript file. And that kind of command, post install node install.js, that looks maybe less dodgy. So how would you hide that into a JavaScript file? So the shell script doesn't have to be part of the source code. You can fetch it dynamically when the post install command is run as well. So what you could do is you could host the shell script in like a URL, so you fetch it, and then you dynamically create that shell script on the victim's computer, and then you use an exec file from Node.js to be running that bash.script.sh. So it means that you could think, oh, maybe the developer who's going to, I want to make sure that maybe even if developers have made their own custom security tools and they're looking if there's a bash script in their open source repository, then you can trick them by not having it in the repository, but just fetching it dynamically when they run post-install. But another way that you could do this as well is that if you don't want to use pre-install or post-install, you could use it like build it, like require it when the module is actually used. So if you were creating like a fake use ML React hook, you could wait for the person to actually import it in their application and then trigger that method and and just fetch the script, and all of a sudden all of their stuff would be completely gone from the computer. So, OK, so that was for protestware and ransomware. But now I want to move to my favorite one called reverse shells. So what is a reverse shell? So it's a tool that allows an attacker to gain remote access to a machine by opening a tunnel between computers. And that allows an attacker to create, modify, delete, and execute files on your machine. So the two or three important things is that you gain remote access. So there's like a tunnel between an attacker and a victim, and you can execute files or commands on another computer without them knowing that you're actually doing this. So by default as well, a reverse shell doesn't have to be malicious at all, but it is a tool that can be used to run cybersecurity attacks. So how do you do that in Node.js? So you kind of need only one command. So if you've never used Netcat, the Netcat tool, it should be pre-installed if you're using a Mac. And that's usually a tool that is used to create reverse shells. So what that command does is that, so there's the same IP address, that's the IP address of the attacker. That's like a home, like local address, but you would change it if you were, depending on your IP address. So what it does is like there's two ports open, port 80 or port 53. The ports don't really matter, you can change that. But what it does is that you have, so it takes all the commands that me as an attacker I'm going to write on port 80, and I'll show you a demo right after that. And it's going to take that command and run it as a bash command and show the output on port 53 in the attacker. And the ampersand at the end is to actually hide that in the background so that as a victim, I have no idea that this is going on. And the way that when you look at this, this is not JavaScript. But again, you could hide that into a Node.js module and use exec file and use run bash script.sh, and you could hide that into a legitimate Node.js module, and you kind of wait for people to download your stuff like 1,000 times a week, and then in one of the versions you just hide that in, and you have reverse shells. So I'm going to try to do a live demo of how that works. Does it? Okay, cool. So it's a little bit small. At first I was thinking like, oh, should I like ask somebody in the audience to be my victim? But then I thought, I don't know who was going to come, so I'll just do it on myself. So here, what I'm going to do is I use the VM. So on the left and middle, I'm going to connect to my VM. And I need to remember the password. Yes, okay, so first one is here. Then, because I have one for port 80 and one for like another one. So, okay, so I'm in my VM. If I look at this and I say, who am I? I'm root because I'm not really on my computer. I am in the cloud, okay? But here on the right, this is my computer. So if I do who am I, I'm Charlie Gerard. If I look at the files, this is Node.js module. And where am I? Like in my Stripe DA path. So what I'm going to do here is I'm going to, using Netcat, I'm going to start listening. And what that does, I'm going to, I freaked out. Okay, so here Netcat is listening on port 80 and port 81. And here, as this is a Node.js module, and I decided to hide my Netcat command in a JavaScript file that I run on post-install, I'm just going to pretend like, oh, npm install. And you can see that the output is like normal, whatever. But what I can do from here, all of a sudden, if I do who am I, that didn't work. Oh, no. Why didn't that work? Let me try again. So I'm listening, and then I'm listening, and then I install, and then, well, it decided not to work now. So I'm going to move on, and I have so I have now I'm confused. Yeah, but like, okay, anyway, so I'm going to show you here. So what you can do if you don't want to subscribe to like a VM, you could use a Raspberry Pi. So I'm at home, and I have a Raspberry Pi that's usually either my attacker or my victim computer. And here are the two attackers' windows. So on my Raspberry Pi, I don't know where I am in the animation. Okay, so I'm listening on the two ports. I'm running a JavaScript script. And here, all of a sudden, on the attacker's computer, I have access to the files that are actually on my Raspberry Pi. So I do who am I, the path, and I can move files from, I can change the names of the files and things like that. So all of a sudden, the name of the file that I was targeting is changed. So, and on the, you can see that on the victim's computer, I can't see anything. Like, there's just, I can't see at all that somebody else is actually looking at what's on my laptop. So what you can do from there, you can change the name of files, you can delete them, you can navigate into the person's computer without them knowing. And you might not have elevated access because you're not like the real user, but you could try to trick the user into giving them, into giving you their password. And then you can have a bit of fun being like, oh, how do I trick the user who doesn't know that I'm actually looking at their computer to give me their password? And you can have fun thinking into doing this. So I'm sorry I couldn't demo it live. I tried it like 10 times. But anyway, so I'm just not lucky. But here you can see that it works. And if you try to do this yourself, it's actually kind of fun. But anyway, so how do you actually hide malware? So I already talked about using install script in package.json, but there's actually a lot of different ways. So using code obfuscation, again, that's a tool that's not necessarily usually used to do bad things as well. It's if you are worried that maybe your victim has certain tools that look for keywords like bash or exec or fetching where things, it shouldn't be fetching. So code obfuscation could make it very hard for a victim to understand what the code that they're installing on their laptop would be doing. And again, in general, you could use a code obfuscation if you're building software that you don't want people to steal, but you still want to make it open source, then you just don't want people to be able to steal your ideas. But in the case of cybersecurity attacks, you could make it just really hard for people to know what they're actually installing. So another one would be to corrupt resolved URLs in package.lock.json. So I don't know about you, but there's many times where I've had PRs from colleagues, and there's so many changes in the package.lock.json that I don't even look at it. But the thing is, you can actually change the resolved URL so that when you run npm install, you might think that you're here installing a data URL to buffer, but actually I've changed the resolved URL to be the name of a different one. And it means that as soon as you're running npm install, you would actually be installing the malicious package instead of the data URL to buffer. And package.lock.json are usually such long files that it would be relatively easy to hide something in there. Another one is called bin script confusion. So this one I haven't been able to recreate it, but I trust the researchers who did it, is that sometimes if you use the bin property in package.json that is usually used for executables, you can trick your code into thinking that when you type node, the name of a file or npm start, it should be using your local files where your malware is instead of going and looking at npm that you install on your laptop. And then finally, VS Code extensions. So if you think, oh, I think that my victim are conscious about security issues, so they're going to look at code on GitHub, usually you kind of know that when people install extensions on VS Code, they don't really go and look at the code. They just be like, oh, yeah, easy, I click buttons and I install, and yeah, I have a cool new theme. But there are, again, VS Code extensions you can create them in JavaScript. So I could actually, I ran a reverse shell using a VS Code extension, locally. You could trust that maybe the marketplace in Microsoft will be looking for things like this, but actually, 2 weeks ago, there was a malicious Microsoft VS Code extension that was stealing passwords and opening remote shells. And what it used is called typo squatting, where the Dracula Dark, super famous theme. So these people created one that was called Darkula Dark. So it's like if you make a typo and you just go quick and it looks kind of the same and you click install, there was more than 45,000 installs of people who mistakenly installed the wrong extension. And then if you don't know, and let's say I don't know if the Dracula Dark theme is open source, but they could steal the code from the open source one, make it look that this one is legit, and while people have a beautiful theme, you actually have a reverse shell open on your computer. And maybe more recently, if you're using ChatGPT, you could start also thinking everybody's talking about how I can just copy and paste and have something working. The thing is sometimes ChatGPT gives you the name of a node module that doesn't exist, but as an attacker, you could think like, well, it doesn't exist yet. And then you create it and you hide malware in it, and then you know that the way people are going to use ChatGPT a lot of the times is like copy, paste, and as soon as you're an npm install to check that this is working, it's too late. You installed the npm package that was fake, but now not fake anymore. So how to actually protect yourself? So you can't really. And the reason why I'm saying that, I'm not saying it to be like, we're all doomed, let's just not even worry about it. What I mean is that there's not a checklist of 10 points that you can go through and then you'll be super safe. So there are things that you can do to mitigate the damage that can be done and to just be a little bit more careful. But people who want to attack you will find a way to do it. And that's why there's zero-day attacks all the time. People just find new vectors and new ways to trick you. So I just have like a kind of boring bullet point list, but I'm going to go through it. So you can use a security tool like Snyk or Socket. There's probably more. If you're working for a company, they are probably already using some things, but maybe your team specifically could be using another tool as well. And for example, with Socket, they have a website, but they have also a CLI where you can enter the name of an NPM package that you want to check, and you kind of get a report. And the graphs at the top here are for the latest version. So the latest version of event source polyfill does not have the protestware in it, so you get like all the green graph. But they still tell you like, hey, at some point in that NPM module, there was protestware. So you decide if you want to install it or not, but you can't really trust the maintainer anymore. So apart from that, you could integrate manual security checks in your workflow. So the same way that now, when you have a pull request, if you're a front-end dev, you're checking for accessibility or responsive design, all that stuff. You can start thinking about, am I, involuntarily adding something that is a little bit weird in my PR that could be exploited in some ways. Another one kind of sounds like maybe obvious, don't install packages you don't need, but you know how we install things and then we don't know the dependencies of the dependencies of the dependencies. But sometimes if you look at what you have installed on your app and you look at the actual code on GitHub, you realize that a lot of NPM packages are just like one function that people were just maybe too lazy to write. So it's, sometimes you look at it and you're like, I could just remove the package and write the function myself. And not only you would, help yourself in terms of security, but then you also you don't have to maintain anymore, and it makes your app a little bit lighter. So, if you have the time, or if you do like bug bashes at work, maybe, looking through your NPM modules and removing the ones you don't need could be a good idea. Regularly update your dependencies. So this one is tricky, because if you do it too often, you might be the victim of a zero-day attack where there's no patches for it yet. But if you don't do it enough, then you don't install the patches, so you're also in trouble. So this one would be very specific to the way that you write your code and where you're at, but it's a good way to think about what's your best strategy. Be careful of typo squatting. That's the one I said when you type it super fast and then you make a typo, and hackers know that, and they're going to create a tool, and too late it will be installed as well. I think that the socket CLI might help you to like avoid typo squatting. Like it will stop the install before you make a typo, but I'm not sure. I think, but you'd have to double check. And finally, so that will also depend on where you work from, but you could start to prepare a cybersecurity disaster recovery plan. And if you have a security team, usually they would do that for you, but you as like a front-end developer, there might be things that you can think of in advance as well. It's like, what if I install a package that is malicious? It's like, who do I contact, or what do I do? How can I check if it has done something to my app, and things like that. So just before I finish, I want to really reiterate that hacking without consent is illegal. And again, that's why if you do it, you could use a VM or you could use a Raspberry Pi. And in general, if you do hacking stuff and you're not sure that you're doing legal or illegal things, I think using a Raspberry Pi or a VM is better than doing it on your laptop. I guess it's less risky. And also, if you mess things up, if you try to do ransomware and you're worried that you're actually going to encrypt your entire computer, it's probably better to do it on a Raspberry Pi that you don't really care about. So I have a list of resources if you want to take a picture, but there's like so much stuff that you can find online that I have no, I'm not worried that you'll find the information that you want if you're interested in. But before I finish, I just wanted to say that the most important thing is like, to me, when I started learning about this and I realized about like, I feel like switching my mindset to thinking like an attacker made me a better developer because I'm more careful. But also, it's like a brand new world of cybersecurity, and I really realized that I've been in the industry for 9 years, and nobody ever told me about any of this, and now I realize the risk that I'm taking every time I run like npm install, whatever. So hopefully you'll be a little bit more careful, and if you can teach other people also how to be careful, and just be on the lookout for what could be a little bit weird, and people can do bad stuff. But anyway. Thank you so much for joining me today, and thank you, the team. Do I just